What's up, math fans? Today I want to do some proofs. Alright, you should be used to the following proofs. Proving two triangles are congruent using conclusions like HL, SAS, SSS, ASA, AAS, and of course you cannot use AAA or ASS. Those two are not legitimate methods of proof, only those first five were. If you missed what I said, just rewind it. I'll say it again, okay? Now, that's if you want to show two triangles are congruent, but what if you already know two triangles are congruent because they said so in the question? Then you can say, well, if I know that this triangle ABC is congruent to this triangle DEF, then I should know that all the parts are congruent. I know that AB is congruent to DE. All the corresponding parts are congruent. So then I would list it. AB, side AB is corresponding and congruent to side DE. And you should be able to list all the corresponding parts and say they're all congruent to each other. You should be able to say BC congruent to EF. You should be able to say AC congruent to DF. But notice I said congruent corresponding parts. Corresponding parts of congruent triangles are congruent. In short, I'm not gonna say that anymore. I'm just gonna say CP, T for triangle, CPCTC. That's what I'm gonna say instead of all that. Too lazy. Shorthand. And it's accepted in the math community anyway. Okay? So you can list all the sides and say they're all congruent. I'm even throwing the angles too. Angle B corresponding and congruent to angle E. And then you can list all the angles too, right? You can say angle A corresponding to angle D and angle C corresponding and congruent to angle F. Right, I'm not going to sit here and list it all. You got the idea. So it helps if you have two congruent triangles, then you can start breaking up the sides and the parts and saying that the parts are congruent to each other. So let's look over here. There's some givens, even though I didn't write the givens. I'm going to ask you to prove that AC is congruent to DC. So I'm going to start with a formal proof. The formal proof starts with two columns, statement, and if you remember, reason. Statement and reason. Okay? Two-column proof like that. The first statement should be all the givens, and since there's no givens in words, I'm going to just have to look carefully. What's given? AB is congruent to DB. How do I know? Because you showed me the little dashes in the diagram, also known as being given. Do you see anything else? Yes, I see these angles here. ABC is congruent to DBC. Don't just call this angle B, it's confusing because there's two parts of it. So say angle ABC is congruent to angle DBC. Why would you say that? Well, there were loops there in the picture, so I guess it was given. That's it? That's not enough. That's not enough information. That's a side and an angle. Is that enough? No, but there's something that's unknown. Hopefully you're used to it by now. Notice that this line BC is in the left triangle and the right triangle. If I was to break it apart and say, hey, look, here's BAC, the left triangle, and here is BDC, the right triangle. If I break it apart, you see that BC is in both, BC is in both. That's important to know. BC on the left is congruent to BC on the right. How dare you say something is congruent to itself? Oh yeah, that's right, you're allowed to say that, and you just call that the reflexive property. So now look carefully, I got side, an angle, and a side of the left. I got a side, an angle, and a side on the right. Now I can say that the two triangles are congruent. Triangle ABC and DBC are congruent. Triangle ABC is congruent to triangle DBC. Why am I allowed to say that? One of those five reasons. Which one can I use? SAS. SAS. But look carefully. I didn't ask you to prove the two triangles are congruent. I asked you to prove that AC is congruent to DC. What is AC? What is DC? AC is this guy. DC is this guy. Those are sides, also known as parts. Those are parts of the triangles. You can't say that the parts are congruent until you say the whole triangle is congruent. Now that you just told me those two triangles are congruent, now you can just start pulling off the parts like I did in that last problem and say whatever you want. So conclusion, number 5, this AC is congruent to DC. And why am I allowed to say that? Because in the previous statement, in number 4, you're telling me that both triangles are congruent, so that means I can make a whole list of parts that are congruent. This just happens to be, this is the one I wanted to say. So, CPCTC, the corresponding parts of the congruent triangles are also congruent. They're corresponding, they're parts. You got me? Good? Let's try that again. Look at number 2. Slide over here so you can copy it down. I'm going to get rid of this proof. Now, here, I actually wrote the givens. And I drew a diagram, but I didn't put any dashes. So this time it's kind of, you got to do that a little bit of work first. You put the dashes. What's given? AE congruent to DE. So I got AE right here and DE right here. That's easy. That'll be my first statement. Then angle A is congruent to angle D. Okay, so that's easy. That'll be my second statement. And both of those reasons are given. So I didn't even have to write erase. See, I left it. Word given. That'll be given also. Those are too easy. We aren't even thinking yet. What else do I know? Is there something that's obvious but not being said to me? Yes. Instead of the reflexive property, now I'm looking at vertical angles. So I'm going to have to say angle E on this side is congruent to angle E on that side. I can even, this would be BEA and this would be DEC. Okay, so say that. And what's the reason for that? Vertical angles. And then you got yourself angle, side, angle. Angle, side, angle. Step 4, angle, side, angle. Okay? So I'm cheating a little bit here. You figure out the statements. I'm just going to give you the reasons. What did I say this was? Oh, excuse me. Vertical. Vertical. Vertical angles are congruent. That's enough to say, to use angle, side, angle. And just like the last one, now I want what? What do I want? I want to prove that AB, this is AB, is congruent to DC. This is DC. What are those? What are those? Those are parts of triangles. How do you prove that parts are congruent? I just told you the two triangles are congruent. So then I'm going to use CPCTC as my last reason. Okay? Very, very similar to number 1. Just fill this in on your own. Obviously, I'm not going to do all the work for you. Any questions? Put in the comment section. Thanks for watching. See ya.